All right, here we go. FRQ, I don't know, what are we on, 3? I don't know, I'm losing it. Okay, so let 6 be the function defined by cosine of 2x plus e to the sine of x. This is a non-calculator question, by the way. Let g be a differentiable function given by the table. So this is g, this is g, this is f, right? It gives you values of g and g prime. And then h, what? Is the function in the graph. Wow, that's 3 functions. Boom. All right, A says, find the slope of the line tangent to the graph of f at x equals pi. So you've got to know what function you're looking at. Super important. So if we want the slope of the line tangent at f, we need f prime of pi, right? That's what we want. I'm going to start with f of x cosine of 2x plus e to the sine of x. I'm going to go ahead and do the derivative, and then I will plug in the pi. So this is going to be chain rule. The derivative of the inside is 2. The derivative of the overall is negative sine, and then the inside is still on the inside. Plus, up here, chain rule again. Derivative of the inside, which is going to be cosine of x, times the derivative of the overall, which is just e, with the inside still on the inside. I should have grabbed colors before I started. Here we go. All right, so this is going to be f prime of pi. I'm going to pull that negative out in front of that 2, and then it's going to be sine of 2 pi plus cosine of pi times e to the sine of pi. So you know what you need to know, right? Your unit circle. So pi is here, 2 pi is here. This is 1, 0. This is negative 1, 0. I love this pen. So if anybody is thinking of giving me an end of the year present, the Sharpie pen, I've never seen those. They have little ties on them, bow ties, and those are so cool. Okay, so we're going to plug in. So we're going to have negative 2. Sine of 2 pi. Sine of 2 pi is 0. So that's going to knock that out. Plus the cosine at pi. The cosine at pi is a negative 1. E sine at pi is 0. And now some people make the mistake of thinking e to the 0 is 0, but e to the 0 is 1. So this whole thing is negative 1. Boom. How did you do? That one was fun. Okay, next, B. Let K, haven't we gotten enough variables already? Let K be the function. I don't even know if I have enough room to do it right here. Let's try it. K of x equals h of f of x. And they want us to find K prime of pi. So let's do K prime of x first. This is chain rule because we have a composition of functions, a function inside of a function. So chain rule is the derivative of the inside times the derivative of the overall with the inside still on the inside. This is fun. Now we're going to plug in the pi. So K prime of pi, it's hard to say, f pi prime of pi, blah, 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 blah. H prime of f of pi. Woo! This is fun. All right, let's see. Do I have another color I can write with here? Oh, good, black. Oh, I like this pen too. I don't know. It's a Pilot G207. I like that pen too. All right, so f prime of pi. Remember how we did that one down here? We already did it. It's negative 1. Now, this is going to take us some steps. H prime, what is f of pi? Well, we haven't done f of pi yet. Let's go back to here where they give us the equation. That would be cosine. So this is f of pi that I'm doing. Always write what you're doing so they know. Cosine of 2 pi plus e sine of pi. Cosine at 2 pi is 1. So that's going to be 1 plus e. Sine at pi, remember, is 0. And so that's going to be 1 plus 1 is 2. So f of pi is a 2. Where am I? I'm right here. H prime of 2. Now, where are we going to go look to see what h prime of 2 is? Remember, this is the graph of h. H prime of 2 is the slope at 2. Let's see. That's 1. Here's 2. So what is this slope? Let's just count. Down 1 over 1, 2, 3. So negative 1 over 3 is the slope. So we have a negative 1 and we have a negative 1/3. So the answer is 1/3, positive 1/3. That is part B. How did you do there? All right, part C. Let m, another function, holy smokes. All right, let's do C down here. I'm running out of space. Let m be the function. I'm going to write it down here. M of x equals g of negative 2x times h of x. And it wants us to find m prime of 2. So here we go. M prime of x. We need chain rule and product rule. Woo! 2 and 1. Here we go. I always do it the same way. I'm going to do the first times the derivative of the second, so h prime of x, plus the second times the derivative of the first. Now, the derivative of the first is chain rule. It's going to be negative 2, because that's the derivative of the inside, times the derivative of the overall, with the inside still on the inside. Can get confusing, right? Yikes. Okay, here we go. It asks for m prime of 2. So we're going to plug in 2's. So if I plug in a 2 right here, negative 2 times 2 is negative 4. H prime of 2 plus h of 2 times negative 2 times g prime of negative 4. So now it's a treasure hunt. You just got to go find all the pieces that fit. Ready? G of negative 4, that's from the chart. Notice we haven't used the chart yet. G of negative 4 is a 5. H prime of 2, where did we do h at? Oh, h prime of 2 we did up here because it was the slope at 2, right? So that's negative 1/3. I like the way we use pieces we've already found. Plus h of 2. Now h of 2 is the value right there. That's complicated because we don't actually know that value exactly. We're going to have to find it. So here we go. H of 2. How are we going to get that? We need, for this little section here, we need the equation of this line. Ready? So y equals negative 1/3 x plus, the nice thing is the b is a 0. So we just have to plug in a 2 right there. So it's going to be a negative 1/3 times 2, which is negative 2/3. That wasn't so bad. So you can't just eyeball it. So that is a negative 2/3 times a negative 2. G prime of negative 4, come back up here. Here's negative 4. G prime of negative 4 is negative 1. So we just got to put it all together. Now it's just elementary school math, right? Negative 5/3. Over here we have a negative times a negative times a negative, so that's 3 negatives, so it's going to stay negative. It's going to be 4/3, which is negative 9/3, which is negative 3. What a nice answer at the end. So that is part C. Woohoo! What kind of question could they possibly ask on part D? This has been a weird FRQ. is there a number C in the closed interval, -5 to -3, such that G prime of C equals -4? Justify your answer. Just reading this about a number C, it's got to be one of the three big ones, right? It's got to be either intermediate value theorem, extreme value theorem, or mean value theorem. It's one of those. So let's go look at the chart. -5 to -3. I'm going to bust out a marker pen here. So from -5 to -3, so we're talking about this section right in here. That's all we have to look at. And it's asking us if G prime, that's this side, can it be a -4, right? I do not know what all that noise is about right now. So in this closed interval from -5 to -3, can there be a derivative that's -4? I want to back up and see where it talked about G. Ready? This is going to be super important. Let G be a differentiable function. That's important because if it's differentiable, that means it's continuous and differentiable. So whenever they're talking about the derivative, it's always, everybody say always, it's always the mean value theorem, okay? So up here, here's what we're going to do. We're going to do between -5 and -3 that they did, we're going to calculate the slope, okay? So we're going to do the slope, which is the same thing as G prime. We're going to approximate it. So we're going to do G of -3 minus G of -5 all over -3 minus -5. That is the formula for slope, right? So G of -3 comes from here. It's a 2. G of -5 is a 10. And -3 minus a -5, add the opposite. It's going to be a 2. 2 minus 10 is -8. Divided by 2 is -4. So what that tells me is that since this is a continuous differentiable function from -5 to -3, then there exists a C such that you get G prime of C equals -4. Does it say to find it? It does not say to find it. It just says to justify. Okay, so we're going to say this. I'm going to do it on the back because I'm running out of room here. Everybody ready? So I'm going to restate it. There exists a C. It's a space C, not like air conditioning. There exists a C on -5 to -3 such that G prime of C equals -4 by the mean value theorem. You could just put MVT if you want to. Because, you ready for the because? Because G is a differentiable, you don't even have to say continuous because they told us it was differentiable, is a differentiable function on -5 to -3. And, you ready? You're just going to say G of -5 minus G of -3, or vice versa, whatever. It doesn't matter because it's going to come out the same. I know that we did it the other way on the other side. It does not matter because you're supposed to go this one minus this one. Boom. Gives you -4. So there is part D. It was the mean value theorem. Ta-da! That was FRQ 3. Number 4 came out today.